Okay, thanks very much, Susan, and thanks for joining us today, everybody. I don't know about you, but I encounter a lot of products that seem to be designed by someone who apparently has never used a product of that kind before. I run into software applications, websites, physical products like cars and household items all the time that just make me wonder what the designer was thinking. Sometimes we might have problems trying to figure out how to use a product, and that can make us feel dumb, but usually it's not our fault. Most of the time, a product that's hard to understand is because it's not very thoughtfully designed. So I wrote this book, The Thoughtless Design of Everyday Things, to share some of my experiences and also a lot of experiences I collected from other people and see what we can learn about them about how to do better product design. So just to avoid being a distraction here, I'm going to turn off my video for the presentation, but I'll come back at the end when we do some Q&A. So I'm going to begin with a definition of what I mean by thoughtless design and describe 3 reasons why design is a hard problem. I don't mean to suggest that it's not. As I was writing this book and collecting several hundred examples of products, both good and poorly designed, I began to see some patterns, and I identified 9 fundamental principles of good design. There are about 160 examples in the book of products that don't conform to those design principles, along with suggestions for how to improve many of those designs. And today I'll show you quite a few examples of these thoughtlessly designed products. But I also describe in the book almost 50 examples of particularly well-designed products in my view. And I'll show you some of those today as well. But, I don't think it should be a pleasant surprise when we encounter a well-designed product. You've probably had that experience. You're using something, you say, wow, people put a lot of thought into this. This really makes sense. But I think that should be the norm. I don't think it should be a surprise, and we shouldn't be astonished by it. We should just expect it. So along the way here, we're going to see around 19 of the 70 design lessons that I extracted as I examined these various kinds of products. I'll wrap up by summarizing some good practices for usage-centered design products. And I didn't say user-centered, I said usage-centered, and there's a subtle difference. And I think that's the best approach to building usable products that people enjoy and feel comfortable using. So what do I mean by thoughtless design? Well, here's an example. I've got a nice blue jacket like this one, not quite the same, but very similar, that I think is well designed overall, but it has one particularly thoughtless feature. There's an inside pocket in the jacket that's about 5 inches wide, and that's a nice size for holding a phone or a museum brochure or sunglasses, something like that. But for some reason, the jacket designer sewed a big seam down the middle of that pocket, thereby splitting it into 2 much smaller and therefore less useful pockets. I just don't understand why somebody would do that. What customer said, hey, this 5-inch pocket is way too big. Why don't you make 2 small pockets instead? I can't imagine that anyone would have made that request. So it's a puzzlement to me, and it does reduce the utility of the jacket, which otherwise I like quite a lot. So when I say something is thoughtlessly designed, I'm thinking of products that violate one or more of my design principles. And the sad thing is that many of these products could have been designed better with little additional effort, just some more careful thinking and some better customer engagement. Let me briefly define a few terms that I'll use here. A product or feature is obvious if its presence and usage are readily apparent without anyone having to explain it to you. It just jumps right out. A product is intuitive if you can make a good guess at how to use it based on its similarity to other products or from other cultural or contextual cues. You don't need to consciously think about how to use it. You don't need to refer to a manual. You just use it because it just feels right. A product or a feature is easy to use if the user can successfully perform a task with minimal effort or assistance. So these kinds of ideas will thread through a lot of what we're talking about here today. So this kind of raises the question, why aren't all products thoughtfully designed? So let's look at some reasons why design is hard. And I don't mean to suggest that product design is easy. It's not. And I think there are 3 major reasons why design is hard. The first problem arises because designs are based on requirements, and we all know how many problems people encounter trying to develop an understanding of requirements for any product. We also have a problem just with our own requirements when we go to buy a product. We don't really think very carefully about it, and sometimes we're disappointed with what we brought home because we discover it doesn't really match what we were trying to get. So in fact, here's a picture on this slide of a very early BA, business analyst, writing one of the very first requirement specifications. Well, all right, I lied. It's actually Charles Dickens, but it could have been a primitive BA there. You never know. So here are some of the reasons why problems with the requirements could lead designers in the wrong direction. Our requirements that we start with to begin our design could be incomplete or inaccurate, or they could be obsolete, that aren't going to be applying to the product the way we want it to be in the future. Sometimes we don't talk to the right people or can't talk to the right people, and so we get input that really is off the mark from what the customer base is really looking for. I've been a software requirements and software process improvement kind of a consultant for more than 25 years. And the one complaint that the people I talk to at my many clients have said more than any other complaint, they say, our customers focus on solutions. They don't focus on telling us their needs. And so if the design is based on a solution without an adequate understanding of the need, there's a pretty good chance that you're not going to come up with the right solution. I'm going to hit this point repeatedly here, but I really strongly recommend focusing design on how people are going to use the products and what they need to do with it. But a lot of times, system design, product development of any kind focuses on its features. And those aren't quite the same thing. So I think it's important to understand usage instead of features, and then we'll figure out what the features need to be once we understand what people need to do with it. We naturally focus on functionality, but those of us who have been in software for a while know that there's also a lot of non-functional requirements that we have to worry about. And we'll come back and see more about that in a moment here. And if you overlook those discussions, then you're going to have a product that maybe does what it wants or what people want it to do, but not in a way that they feel comfortable with. And even if we can overcome all those shortcomings and challenges, we can come up with a good set of requirements, but we still might not record them accurately or in a clear way and communicate that to all the people who need to do work based on those requirements. So there are a lot of reasons why the foundation for design in the requirements can lead us astray. Another reason why design is hard is that we have multiple stakeholders that we need to please. Got a whole bunch of them, and I've just shown some typical types of stakeholders that you might encounter on your projects here. And so it's important to remember that perfect design solutions are unattainable. Any solution is always a compromise. These various stakeholders that we have to try to please can have conflicting interests and objectives. So one source of tension in the design process is trying to satisfy the complete set of requirements and constraints that these diverse stakeholders present. So for instance, certain product characteristics might make it easier to install or to service some product, but maybe some of those same characteristics make the product less convenient for users. Or the manufacturer might like a design that's easy and cheap to produce, but that's not going to make your customers very happy if it makes the product, say, less durable. Also, you'll see here at the bottom, I've got several arrows pointing towards multiple user classes. Sometimes people talk about the user for a product. But in fact, most products have a diverse group of users who we can group into user classes who have similar sets of requirements. But the user classes themselves have different characteristics, different needs, different expectations. So from all this, it turns out it's very hard to make all of your stakeholders ecstatic with any single design. You're not going to get a perfect design for everybody. A third reason why design is hard is because a product exhibits many different quality characteristics. These are sometimes called design for attributes. In software, we call them quality attributes. Here's a list of some of the familiar design for attributes for software systems shown on the left: availability, efficiency, and so forth. A lot of these are called the ILITs because many of them do end in ILITY. but not all of them. And then there's a supplemental list in the right column here of some of the additional design for attributes that are important for physical devices, physical products that often contain embedded software. In fact, if you're building something with embedded software, you have to worry about both of these lists. And the bad news is that it's impossible to build a product that maximizes all of the desirable attributes. Also, some of these attributes conflict with each other. Increasing one can decrease another. So for example, suppose you're interested in security. For many applications these days, security is a pretty important attribute. So some of the things that you might do to make a product or a phone app more secure, such as multi-factor authentication, actually impair usability. And so there are these trade-offs that are just kind of unavoidable. Therefore, the designers need to know which of these quality attributes are most important to business success, so they can make the right design choices and try to achieve the best balance. So that's why an exploration of these quality attributes, these design for characteristics, is such an important part of requirements development. And if you overlook those, then it's pretty hard to glue them back in at the end. It's not just like pasting in some new feature that you just thought of. So there are three reasons there why design, I think, is a hard problem. Now, as I mentioned, this book presents 70 design lessons that I derived from observing both poorly and well-designed products. And here are the first three lessons, which I think are the most important. Remember I said we come back to this, the idea that usage-centric design is more important than focusing on product features. That's our first lesson. Usage-centric design means understanding how people will use the product. Think about what people want to do with it and the environment in which they'll be using it. Then figure out what features it has to have and what design characteristics it has to have to make it easy for users to get that job done. Second important lesson is that design demands iteration. You're not going to get the design right on the first try, almost certainly. You have to plan to iterate, approaching a better design with each cycle until you have a design that's good enough to satisfy all those requirements. Well, if you're iterating on your design, how do you know what to change on the next cycle? Ideally, you'll have typical user representatives working with a prototype or a mock-up of the product under realistic usage conditions. So these users will give you insights that you just can't get in the design lab on your own with just the designers involved. So sometimes you can't get real users to participate for one reason or another. Sometimes you have to work with user surrogates or create personas to represent what you think the users need. But there's no substitute in my mind for having real users participate in the design process whenever possible. So now I want to look at my 9 design principles, and we'll see some product examples and some more design lessons. It was interesting when I was writing this book, I contacted a lot of people and asked them for ideas and input. And I received many, many examples and many more since the book came out last year. Many examples from people. So these aren't just my own observations and experiences, but I've got a lot of input from many people because we've all had these kinds of frustrating experiences with products that just don't make sense to us. So the first design principle, I think, should hardly require stating. Make the product easy and obvious to use. We shouldn't even have to say that. But let me give you an example of what happens if we don't do a good job of that. So a couple of years ago, I rented a small SUV at an airport, and here's a picture of the back of that SUV. Now, I don't have a lot of experience with SUVs. I've always driven sedans. But, it's a car, right? So I was trying to figure out how to open the hatchback here, the tailgate, whatever you call it, on an SUV to be able to put my suitcase in the back. And I spent 10 minutes groping around in this dimly lit garage at the airport looking for a latch, a handle, a button, a keyhole, anything. I couldn't find it. There was no button on the key fob, as there usually is on cars I've owned. There's just a button you can press and pop the trunk open. So I looked inside the driver's area and I couldn't find a button or a lever or anywhere inside the car to open the tailgate. I finally had to ask the rental car people for assistance. Now, here's where it is. The red oval on this photo shows the door opening handle on the right side above the right taillight, and that looks very much like the non-functional chrome piece above the left taillight. Is that obvious to you? It was not obvious to me. And when I related this story, it turned out that another guy, a friend of mine, had rented the exact same model of car, and he had the exact same problem that I did, trying to figure this out. And we've both driven lots and lots of rental cars, so you just wouldn't expect that we'd have trouble figuring out how to do something simple like open up the back. So the lesson I learned from this is that small design problems can interact to yield unexpectedly significant results. This combination of having this cleverly disguised handle on the back, no opener inside the car, and no button on the key fob, each of those was a small design choice. But by putting them all together, it made it impossible for me to open the tailgate, despite my having driven dozens of different rental cars in my long career as a consultant. It wasn't intuitive, it wasn't obvious. Now, it wouldn't have been much harder to provide these multiple alternative opening mechanisms that people are used to. And this is the kind of problem that should be discoverable before a prototype or before we actually start manufacturing products by doing some prototype evaluations. You know, if you're coming up with a design that's novel, and this is fairly novel, I think, I can see why they did it. It's kind of an aesthetic appearance to it. But that's the time you want to do a prototype and have people play with it and see how hard it is for them to learn it if they've never seen something like that before. Now, it turned out that once I figured this out, okay, that was one problem solved. But actually, over the course of my week-long trip with this vehicle, it only opened about half the time, and there was no other way to open it. So I actually ended up leaving my suitcase in the back seat because I didn't trust it to open up when I got to the airport. So not only was there a design problem, there was some kind of manufacturing problem or something as well. Pretty frustrating. So here's another example of an unobvious design. I've got a lot of iPhone examples in the book. I'm only familiar with iPhones. I haven't used Android phones, but I'm sure they have their own characteristics. I've got some silly examples like the one I'm going to show you here, but there's also some very good examples. There's some very clever design involved in the iPhone as well. So this is the timer feature on my iPhone. The image here on the left shows how the timer looks when it's counting down, in this case from 5 seconds. Now the image on the right shows what the screen looks like after the timer countdown has reached 0. So how did I learn about this? Okay, a very smart friend of mine with almost 50 years of software development experience used this timer when we were playing a game one night. He set the timer for 30 seconds, and sure enough, the alarm sounded when it got to the end. However, it took him, with help from the rest of us, all technical people, 30 more seconds to figure out how to turn the alarm off. It was totally unobvious from this screen on the right. So let's look at some possibilities here. Hey, there's a cancel button. Okay, well, cancel doesn't do anything at all. You'll notice it's grayed out. Well, it was gray on the first screen on the left when we started the timer and while it was running. It's just a darker gray. What does that mean? That doesn't help me. Well, maybe the start button does something. So here's what the start does. If you tap start after it's completed one countdown cycle, then it starts a new timer countdown cycle. The alarm is still sounding from the first one, and then the alarm goes off after that second timer reaches 0. And that just doesn't make any sense to me at all. So one of the lessons I drew from this app was that it's a bad idea to provide the user with options like the cancel button here that don't do anything or that suggest they'll do something different from what they actually do. So the lesson is to present the user only with unambiguous and useful options. Now, it turns out there are several ways you can turn off the alarm. You can press the home button on the phone. You see this gray bar up at the top. You could tap that, which wasn't at all obvious, and that will turn it off. But wouldn't it be better to show that to the user somehow? Well, if you pull down on that little gray bar at the top of the right-hand screen, then you do get the options to either repeat or stop the alarm. But I think I shouldn't have had to take that unobvious step to figure it out. Let's not make the user take steps that they don't need to so that they can get their job done. It was pretty weird. So I encountered some surprising behavior in Microsoft Excel. I had made some changes in a workbook that was still open, and that caused the undo function to become active. Okay, that makes sense. Well, when I then created a new workbook, I noticed up here at the right, you see I've got a circle, the undo shortcut button on my toolbar was still active in that second workbook, but I hadn't done anything yet in that second workbook. I just created it, and all of a sudden Excel is offering an undo. There was nothing to undo in that context. That puzzled me. So naturally, I had to figure out what would happen if I clicked on it. So I did. And here's what happened. Excel reversed my most recent operation from the first workbook. The view also switched back to that first workbook after it did the undo, so I couldn't tell what had happened. It was pretty confusing. Now, this is not how undo works in PowerPoint or Word. We expect that members of a product family like those in Microsoft Office will show common behaviors from the same functions, and most of the time it does, but not always. So the first lesson here is to make sure the user won't be surprised by unexpected and undesired behavior. But there's a second lesson as well, and that we should use the context of the operation to activate relevant functions. And in my mind, there's no point in having undo be active if there's nothing to be undone in the present context. That's not how undo works in PowerPoint or Word. If you have multiple documents open, they each have their own undo cue. All right, let's move on to my second design principle, that we should consider realistic usage scenarios. So last year I bought a new wall oven. Here's the control panel for it. And I like the oven okay. My previous one had a literal meltdown experience. It was quite exciting. So I bought this new oven, and it has, it's pretty usable, but it has one absurd feature. Now, one thing you want to do with an oven is use a timer. Back to the timers again. This oven does have a timer that sounds an alarm when it counts down to 0, or if it hits a preset temperature and wants to let you know, go ahead and put your food in. But that alarm is way too quiet. If you're more than a few feet away, you are unlikely to be able to even hear it. And normal background noise will just basically make that impossible to hear. So I came up with this thoughtfulness scale that describes how this oven's alarm feature was designed. The nominal behavior is that the oven does generate sound effects under appropriate conditions. The designers thoughtfully allow the user to set the volume to one of 3 levels. That's a nice capability. But the highest volume setting is still so quiet as to fit in the thoughtless design category. I thought there was something wrong with my oven. I actually called the manufacturer and said, "This is what it's doing, is that right?" And the person I spoke to kind of sheepishly said, "Yeah, that's the way it was designed. It's quiet," which kind of defeats the whole purpose of having an alarm. But there's another level here on this scale, and that's that the lowest volume setting is just comical. You have to stand right next to the oven to hear it, which defeats the whole purpose of having an alarm. My old oven, I could hear across the room with a loud buzzer, which was, a little more raucous than the tinkle I get from this one, but I could hear it. So I think maybe this oven was not adequately tested in realistic home usage scenarios. This one sounds kind of like the gentle tinkle of a distant ice cream truck. And sometimes, if I'm not really paying careful attention, the sound just barely penetrates my consciousness, and I might miss it entirely. Kind of frustrating. It seems obvious that products should be designed so people can use them effectively in a wide range of normal, realistic usage contexts, but sadly, that's not always the case. Have you ever seen silverware at a restaurant or a cafeteria that has smooth, cylindrical handles like these? It's impossible to get a secure grip on them. The knife rolls in your hand if you're trying to cut a piece of meat or butter some bread. Eating cereal or soup with a spoon requires careful attention to make sure it doesn't spin and spill food in your lap. I just cannot imagine why someone would design such an everyday product in a way that simply doesn't work well in an ordinary usage context, that is, eating. Our hands grip flattened and textured pieces of metal far more securely than these smooth cylinders. This is an example of the kind of design that makes no sense to me at all. And yet you can actually buy these for your own home too. I've seen them for sale online. As I mentioned, I have many examples in the book of iPhone design. Some of them are great and others are ridiculous. But here's one that I think is pretty thoughtful, the Contacts app. Some good ideas here. So for instance, the input controls change depending on which field you're entering content into. If I'm setting up a new contact here, I've got an email field and the alphabetic keyboard pops up. Well, it makes sense. I don't know why they included the emoticons and the space bar in this, as I don't think those can appear in an email address legitimately. But my thought is there may be reusing a standard keyboard control there. And reuse is great. I mean, reuse is a tremendous way to be more efficient in the way we build our products. But sometimes there are compromises if something's not an exact fit. So it doesn't really do much harm to put spacebar and emoticon in a email keyboard. It's not useful, but it might have been more efficient just to reuse it. Now, if you're entering content into a date field, Apple has a rotary date entry control that I showed here. And that's helpful. You know, you can't enter something wrong. I also found that if you're entering a phone number, the numeric keyboard pops up with the special characters you might need. So this is thoughtful design because using context to activate these appropriate controls saves the user time and it reduces user errors. I can't put an invalid month in the date field if I can only choose from the 12 months of the year in the control they provide like this. I've seen controls in other applications that did let users enter invalid dates like February 30th. Now, that's not good. And if you've got controls that constrain input to correct legal values, you don't have to worry as much about writing all the code to validate the inputs and then reporting errors and then letting the user fix it and so forth. So preventing errors is a better approach here. So I like this approach. So the third principle is that we should consider a wide range of usage environments. That also seems kind of reasonable to me or obvious. So here's an example to illustrate this. I've rented a car in January a few years ago. Here's a photo of the climate control system for this car. Now, I've rented this model of car many times. It's a common rental car model. And generally, they're pretty nice cars. And this is a nice looking control panel for the climate control. It has clearly labeled buttons and a reasonable layout, nice symmetry here and everything. However, I found that I kept hitting multiple buttons when I tried to adjust the controls with gloves on. Remember, this is January. Some of the buttons were too small and too close together. So for instance, see that pair that I put in the circle? The one on the left is for the seat warmer, the one on the right is for the rear defroster. So I pressed the rear defroster button, but usually my gloved finger would also hit the seat heater button, which is smaller and right next to it. So when you're manipulating the controls of an unfamiliar car while you're driving, maybe at night, that's hard enough. But then when you get an unexpected outcome like, wait a minute, why is my seat getting hot? I didn't turn anything on. That's annoying to have to figure out what's going on and say, oh, yes, I guess I did turn that on, but I didn't mean to. So the lesson from this is we should ensure that the design is usable and safe in a wide variety of likely operating environments and conditions. And I wonder if the designer of this climate control panel ever had someone test the design while wearing gloves, which is, a time when you might actually want to manipulate the heat. I kind of doubt it. This is the kind of problem that you see in a lot of places where the controls may look nice, but they're not really designed for good usability and error-free navigation here. So if you're building a system that contains software and it's supposed to be used in a variety of environments, here are some factors to consider. If it's going to be used under outdoor conditions, check to make sure that it works properly in different lighting and weather situations. I've seen ATMs whose screens were nearly impossible to read at times because of screen glare from the sun. If a product involves audible input or output, like speech recognition or synthesize speech from, say, a kiosk or something, make sure the sound levels are appropriate for the intended operating environment. They're loud enough for the user to hear, but not so loud as to disturb others nearby. So check the environment it's going to be in, because you could end up with something that's supposed to be maybe accepting speech recognition input. And if you've got background noise that makes it hard for the product to get good recognition, that's a problem. I run into that actually in my own car. My Honda does have speech recognition, which is kind of cool. And it works about 10% of the time because the recognition quality is terrible. And just, I don't know what all the problems are with it, but you could have road noise or wind noise or something where it's just not going to be able to hear what you're trying to say. But it's really crappy. Very annoying. I don't ever use it. The fourth design principle is to make it hard to make a mistake. And here's an example of one that's too easy to make a mistake. These controls are from my brother's pickup truck. The knob on the left controls the headlights. The identical knob, a couple of inches to the right, controls four-wheel drive. My brother's a mechanical engineer, and he's driven a lot of trucks, and he says it's easy for him to just reach down and grab the wrong knob, which could lead to some startling results. You know, you're trying to turn your headlights on, and instead, all of a sudden, you feel the vehicle lurch into four-wheel drive. So symmetry like this is nice for visual design, but it's not so good for usability, especially by touch. There are 4 ways a designer can consider how to deal with user mistakes. The best option is to make it impossible for the user to make a mistake. And that's what having like those input controls I showed on the iPhone, it makes it impossible to make a mistake if the input control only allows you to select valid entries. That's great. That's not always feasible. So a good alternative is to make it difficult for the user to make a mistake. So maybe the designer could have made these knobs different enough that a driver could tell by feel if they had reached down and got the correct knob. A third option is to make it as easy as possible for the user to recover from an error, either one of their own making or a system error that takes place. And the fourth option, the worst option, is just not to give it a thought. Just let the mistake happen and then force the user to deal with it. So the principle here is that we want to make products easy to use correctly, but hard to use incorrectly. Let's see some more examples. One good design approach is to make it difficult for the user to take some destructive action by accident. And this means making the options clear so the user isn't surprised by what happens when they take some action. Oh, here's the screen I see if I ask to delete a mailbox, which is just an email address, at the control panel for my website. My web hosting provider, Tiger Technologies, makes it perfectly clear what will happen if I choose this option. They can give me all this description here. And I need to take another step. I need to tick this checkbox to confirm that I want to delete the mailbox. And only then does the grayed out button at the bottom to actually execute the delete action become active. So they've tried to make it hard for me to do something potentially destructive by mistake. But even better, and I just love my web hosting provider. They don't have a fancy website, but they've got a very functional website. So even better than just helping me not make a mistake by accident here, after I delete the mailbox, I see another message that says, if you did this by mistake, you can recreate the address right there on that same page, and it will automatically restore the deleted mail. So they've given me an undo option. Even better, my web hosting provider gives me a month to correct a mailbox that I deleted by mistake. So I think that's all very considerate and thoughtful design. I appreciate them considering about the ways that people might do something they didn't really quite mean to do. So here are some suggestions about how to design products to help users avoid mistakes in these 4 categories. First, we'd like to try to make mistakes impossible. How do we do that? Well, physical products sometimes use asymmetry to make sure that the pieces all fit together properly. For example, there's only one way to connect a USB cable to a USB port. Unfortunately, you have to see both ends to be able to connect them properly, which is a big disadvantage. Sometimes I'm trying to plug a USB cable into a port, maybe at the back of a computer or even in my car is kind of tucked away and you can't see the other side. So that's a problem. And there's at least a 50% chance that I'm going to get it wrong on my first try. Now the USB-C and the Apple Lightning plugs are symmetrical, so you can't get it wrong. There's only, well, there are two ways to plug it in, but they both work just fine. And that's the perfect solution. For software, let's don't offer the user any options that are logically impossible. I used to use a bank when I lived in upstate New York. They had an ATM, and whenever I wanted to make a withdrawal or a deposit, it would always ask me, which account do you want to use? It gave me four choices: primary or secondary checking, primary or secondary savings. Now guess how many accounts I had at the bank? That's right, one. And so by giving me four choices, three of which make no sense, and of course I have to guess which one they mean by primary and which one they mean by secondary, that's just dumb, because it requires, well, it gives the user opportunities to make mistakes and then requires the developers to handle all of those mistakes. Well, software can make it better by not even giving me those choices. Software can also help prevent mistakes by constraining or correcting or reformatting user input, instead of letting people put in something that's invalid, reporting an error, and making the user fix it. And you see this, for example, if you're entering a credit card number or a phone number or a date in a web form. Excuse me. Some of them will just take what you put in and tell you all the things you did wrong. And some of them will format it properly, putting in hyphens like in a social security number or something like that. They'll put in hyphens or other punctuation or spacing to make sure that you get it right. I appreciate that kind of thoughtfulness. Well, our errors are going to happen anyway, so if an error happens, the product should help the user correct it, make it easy to recover. So don't think of a problem report as being just an error message. You could just beep if you wanted to do that. Instead, make the messages be a guide to recovery from the error. Now, if you're just going to let it happen and you're not going to, try to prevent any of these other mistakes and use these other thought processes, if you're just going to let it happen and force the user to deal with whatever results, now you don't need any tips from me. You can do that just fine on your own. I'm sure you've seen messages from computers that are just as useful as the one this guy is holding. Those kinds of messages make you wonder, why are you telling me this? And what am I supposed to do with that information? So instead of just pointing out error, why don't we try to provide meaningful feedback to our users? There are 7 characteristics that meaningful error messages and other system feedback should exhibit. It should be immediate. You should see it as soon as the error condition is detected so that you can deal with it as necessary. They should tell me something I don't know and need to know, make them informative. The messages or the feedback should be necessary. One website I use sometimes shows me a message when I log in that I have a notification. But when I click on the icon to access my notifications, all it says is, you have no notifications. That's an example of unnecessary and time-wasting feedback. I don't like things that waste my time. The messages need to be clear. I need to understand the point of the message. Otherwise, why bother showing it to me? And system error fits in the category of, what do you want me to do with that information? Messages should be actionable. Help me know what to do next. Don't you hate messages that flash by long enough for you to see that there was a message, but not long enough to read it and process it? Someone else decided how fast you think and read. And so I think messages that aren't persistent are kind of annoying. Finally, messages should be polite, and I'll show you an example of some polite feedback in a moment. Let's see a few more examples here first. Feedback should be clear. I wanted to cancel a magazine subscription, and this is the dialog box that I saw when I submitted my request. Are you sure you want to cancel your subscription to this magazine? Okay, cancel. Well, this is ambiguous. Those are the classic Windows yes, no type buttons that have been around for decades now. But I'm not sure what's going to happen. If I click on cancel, will it cancel my subscription like I'm requesting? Or will it cancel out of this dialog? Not too sure. Well, we can do better than that. Rather than using those traditional OK and cancel kind of button labels, let's give buttons meaningful labels that logically answer the question the dialog box is asking. This way, the user knows exactly what will happen if they click on each button. So instead of saying OK and cancel, why don't we say yes, cancel it, no, keep it? Those answer the question. Also, the buttons don't have to look alike. You could design buttons that make it harder for the user to hit one by mistake that would be more destructive. So we might use a big green button for the safe option and a smaller red button for the riskier option. We're trying to give the user clues and make it easy for them to not do something they don't intend to do. So you've probably encountered those kinds of situations yourself. So the feedback you provide to a user should also let them know what to do next. And here's an error message that I often see after I make a backup from my PC to an external hard drive. Then I try to eject the drive. And I see this message, Windows can't stop, blah, 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 because the program is still using it. Close any programs that might be using the device, then try again later. Well, that's not terribly helpful. Windows clearly knows what programs are currently using it, but it doesn't tell me what they are. It doesn't give me any way to turn them off. All I can do is close this message box and then try to figure it out on my own. That's pretty frustrating and annoying. Now let's contrast this message with the far more helpful message I get if I try to delete or rename or move a file that's open in an application. This action can't be completed because the file is open in Microsoft Word. Close the file and try again, and it tells me exactly what's going on. So this is a nicely actionable message that tells me what's happening and what to do about it. So don't think of this kind of feedback as error messages, but as guidance to help the user solve a problem. Here's an example of thoughtful design. I use Mozilla Thunderbird for email. Thunderbird looks for keywords that suggest you might have an attachment for an email you're writing. If it doesn't find an attachment, then when you attempt to send it, you'll see this friendly reminder politely inquiring whether you meant to add an attachment. Notice how the buttons are labeled in a way that answers the question, so you know exactly what will result from each action. Oh, no, I didn't forget. Go ahead and send it. Oh, I did. Okay. So this message hits all 7 of the desirable characteristics of feedback to the user. So wouldn't it be nice if all the messages we saw from computer systems and hardware devices were like that? I think that would be nice. So I mentioned that I don't like to have my time wasted, and that's actually one of my design principles is don't waste the user's time. Let me show you an example here. This is the home page for a financial services website that I use. This page is 100% content free. I don't know who that guy is or why I'm looking at him. What I do want to do is log into my account, and the login fields are below the fold. That is, I have to scroll down to access them. Although there's a tiny little button in the upper right here that says log on. I've circled in red. Doesn't exactly jump out at you. But for the most part, I still have to take an extra action. I have to click on that button or I have to scroll down to see the login fields. So making me take extra actions like that wastes my time. Now, maybe the company did some research and found that the majority of users who land on this page do want to look at that guy with his cup of coffee and click on their promotional link there. But I doubt it. I'll bet most people who see this page just want to log into their account or look something up as efficiently as possible. Some other time wasters include this currently fashionable website design that's got huge fonts, meaningless stock images, and lots of white space that require the user to scroll to get to anything you're interested in. It's pretty frustrating. Sometimes I waste time trying to find the logout button on a website or a phone app. Cleverly concealed options like that make me wonder if the site owner doesn't really want to let me log out very easily. But that's my choice. It should be easy to find the logout button. So the lesson here is to let the user take as few actions as possible to perform a task. And in the interest of not wasting the user's time, the designer should also make it easy for users to access the tasks they perform most frequently. A good way to decide how to lay out screens is to collect some data on how people use the application. An operational profile defines what percentage of the time users will perform various tasks. This helps the user experience designers set defaults and priorities for screen layouts and menu items to save the user's time. So here's a screenshot from a financial services provider, another one that I use. They apparently have collected data on the frequency of different kinds of transfers and payments. They put the one that's used the most frequently at the top, even labeled it most used, and that is indeed the one that I always use. So this layout saves me time, and there were more options beyond these three, so I would have had to scroll around to try to find one. But since they've put the one that people do most of the time right there on top, that saves time for people. Now, avoiding one or two clicks or scrolls, that might not seem like much of a time savings, but multiply that times millions of users and many millions of sessions, and that's a lot of clicks and a lot of time saved. Too many application designers seem to view their customers' time as being free. It is not. One morning I went shopping at two supermarkets. The cashier at one was friendly and efficient, and before I knew it, my bags were full and I had the receipt. The cashier at the other store, though, kept giving me instructions. I had to do things in a certain order. The cashier became impatient with me if I took too long pulling out my loyalty card or making payment. I might have forgotten to mention that the first cashier was a pleasant young woman and the cashier at the second store was this machine. It's hard to think of a product less thoughtfully designed for the user's convenience than your typical supermarket self-checkout station. Some of them are better than others. If you're doing something simple that doesn't require anything being weighed, no products without a barcode, no coupons, no alcohol, then they may be okay. But a lot of the times they're problematic. I've had so many difficulties with these things, and it's not like I'm unfamiliar with using electronic devices. I remember one time I went into a store to buy 3 items with a self-checkout machine, and it called for assistance 3 times for 3 items. I've been known to just leave my food there and walk out in disgust and go to a different store. So the lesson here is that the product should be designed to tolerate both technical faults and unexpected, imprecise human behavior. And here are some other lessons relating to the idea of designing for the user's convenience. Letting users customize their experience whenever possible is a big help. Customization is a way to reach a good balance between ease of learning and ease of use, and to make a product usable by a wide range of customers. For example, my car lets me customize many aspects of its behavior. It's very convenient. Another way to enhance the user's convenience is to let the computer do as much work as possible. For instance, have you ever typed in some long entry like in a problem report in a form online, only to be told when you try to submit it that it's too long, but they didn't tell you what the maximum length was, so you don't know how much to take out? So if you have an input field with a character limit, don't make the user guess at how many characters they can enter. Tell them how many they can enter and how many they have left, and stop taking input once they've reached that limit, instead of showing them an error message at the end and saying, you're wrong. Another good way to consider the user's convenience is to design packaging for physical products that customers can open easily and safely. I just don't understand why we experience so many packaging failures. I have numerous examples in the book, and I encounter those daily at my house. I'm sure you've had your own experiences with poorly designed packages. Why is this a problem? Cardboard and plastic are not new technologies. I shouldn't have to fight with every box of cereal I want to open. Oops, sorry. My mouse just went wild here. All right, so the word thoughtless can mean either showing a lack of thought or being inconsiderate of others. And so far, we've seen examples of products that showed a lack of thought in their design. But some websites, I think, are deliberately inconsiderate of the users, and some are designed to be downright devious. Here's an example from the website of another bank I use that issued one of my 2 credit cards. When I go to pay my bill, this payment page doesn't show me how much I owe. It only shows the minimum payment that's due of $25 in 3 places on this page in the red boxes. I have to take another action. I have to click on this little e-bills link right here in the middle in the red oval to find out how much I actually owe them this month. And I think this website is clearly designed for the benefit of the business, not the customer. That's the exact opposite of what I think is important. We want to design for the benefit of the consumer over the business. These people are trying to get me to pay just the minimum payment each month so they can charge me millions of dollars of interest. So there's all kinds of so-called dark patterns like this, ranging from various subtle deceptions, which I would consider this, to downright fraud. You have to be careful to understand just what will happen when you click on some button. The eighth design principle is we should accommodate the range of human variation. Okay, people come in lots of different flavors. They span a very wide range of differences in multiple dimensions. I've shown just some of them here. And it may be impossible to make every product equally usable by everybody, but designers should respect these variations and be as inclusive as possible. Let me give you two examples of thoughtless design that don't account for some of that human variation. Two of my friends reported the same design problem. One is a man in his late 60s, the other is a woman in her late 70s. They both live in condos in different retirement communities in different states, so these are totally unconnected. But in both of them, they have the same problem. The furnace filters in their condos, which of course need to be replaced periodically, are installed at the top of a 12-foot high ceiling. Now, the condo designers knew that these were for older people, some with disabilities, so this is just inconsiderate design. Another friend works for a utility company. She creates maps of access roads so people can get in to service power transformers and the like. And these roads are color-coded, but the people who defined the mapping conventions chose colors that some colorblind drivers can't distinguish. Color blindness is quite common, particularly in men, so any visual display needs to account for the possibility of users with color vision variations. I found websites that will will let you see what your website looks like in different, for people with different kinds of color sensitivities, so that you can see, if I do it this way, people can't tell that from one object from another object, so you can change the colors. So that's a helpful kind of website. So here are two thoughtfully designed products that do accommodate some of that range of human variation a little better. About 10% of the population is left-handed, but a lot of products are much easier for right-handed people to use. But these days, many computer mice are symmetrical, and the computer operating system lets you configure the buttons to be logical for either right or left-handed people. This illustrates how making systems configurable and customizable increases their usability. I don't know about you, but I'm still wearing a mask whenever I go into a store. And the one problem with masks, other than just being annoying in general, although a good idea, is that they pose a communication barrier for people who are hearing impaired and read lips. But then they're also a problem for medical professionals, because a lot of the emotional communication that we do with our faces is, through the lower half of our face. And so that can be kind of off-putting. You can't really see what people are thinking or how they're expressing themselves. So some companies have designed masks like this one with clear plastic, so you can see the person behind the mask. I think that's both clever and considerate design. All right, just one moment here. My final design principle is to place the minimum mental burden on the user. All right, here's the screen I see when I ask to log out of one website that I use periodically. This is a government website. It says, "Are you sure you want to log out? Any unsaved data will be lost." It's warning me. But that's the problem. The system knows if I have left any data unsaved during my session. I don't know. It should only warn me about this if I really do have unsaved data. And if so, what is the data and where is it? How do I get back to the right screen to do something about it? This is an example of non-actionable user feedback. I don't know what I'm supposed to do with this information, except maybe get nervous that perhaps I did something wrong. What do I do next? So the simple improvement of warning the user only when there really is unsaved data and then helping them to fix the problem that would completely solve the difficulty with this design. Another important lesson is to make sure that the functionality that is shared by multiple members of a product family is consistent. We saw this a little bit earlier. This enhances both ease of learning and ease of use, and it facilitates software reuse. For example, have you ever noticed how many different ways there are to delete objects on the iPhone? The prompts and icons and actions all vary depending on what kind of item you're deleting. Sometimes you need to confirm the deletion, sometimes you don't. You might have to confirm the deletion of a single object, but maybe not a whole group of the same items, although that seems a little more riskier and destructive to me. It seems like the teams that built each of these apps decided to implement the delete function however they wanted to, with no overarching consistent architecture. So I think this confuses users and it increases their learning curve and their error rate. Another inconsistency does show up in Microsoft Office. We saw earlier that there was some weirdness in how the undo worked between Excel and the others. We do expect a lot of common behavior, and there is a lot, but there are enough inconsistencies to be puzzling if I try to do something that works in one or two applications, but not all of them. And here are a couple examples of how shortcut keys work one way in Word and PowerPoint. They work differently in Excel. All that does is cause confusion. I'd like to wrap up by summarizing several good practices that can lead to more thoughtful designs of any product. If you agree with my premise that usage-centered design is superior to product or feature-centered design, then let's begin by understanding our stakeholders. Customers constitute a subset of stakeholders, and user classes are various subsets of customers. Remember that just about every product doesn't have a type of user. It has multiple user classes, all of whose needs the design must address. So during requirements development and design, you need to engage appropriate customer representatives of these various user classes so that you can understand their needs and have them help validate the solution ideas you come up with. I call these user class representatives product champions. So our product champions would work with a requirements analyst, a business analyst, a product manager, a product owner to bridge the gap between customers who have needs and developers who can craft solutions. So I think that's a very important starting point for any kind of a design. Some other good practices. You might decide to create personas to serve as stand-ins for human beings when you don't have a real person who can represent a particular user community. A persona is kind of a hypothetical person that you characterize and imagine what their properties and needs and interests and concerns would be, and use them as a stand-in whenever you don't have a real person to work with you. But a real person is going to be better. Prototyping is an excellent way to iteratively understand requirements and to evolve designs. A prototype is a partial, preliminary, or possible solution to your problem. It's a lot easier for users to envision what a product might be like and how they would use it by interacting with a tangible prototype instead of just looking at a bunch of textual requirements and diagrams. So here's a cycle of steps you might go through when you're using prototypes to design a product. You develop some initial requirements by having customers work with an analyst, say, and that gives us enough information to conceive at least a possible solution. We can then create a prototype to implement portions of that solution that maybe we're not sure about or want to explore several alternative variations. Get some customers to evaluate the prototype and provide feedback, which helps us both refine our understanding of the problem and refine our requirements so we can go back and then iterate by coming up with better solutions. And you do this as needed until we feel comfortable that the solution we've ultimately got is going to be as good as we need it to be. Usability testing is very valuable as well. Even informal usability testing can reveal places where users are confused, make mistakes, or take too many steps to get something done. The simplest approach is simply to watch people try to use your product or a prototype of it. But if you're really serious about usability, you can do formal usability testing. I once participated in a usability study like that in used in an IBM usability testing lab many years ago. It was kind of interesting and fun to sit there with cameras on my hands and on the screen, and I had a microphone. I was just supposed to free associate and describe what I was thinking and trying to do, and that gave them observers a lot of feedback so they could understand why maybe I had trouble doing something. Finally, every organization should learn from its previous experiences so it can do the next job even better. Project retrospectives and collecting and analyzing customer feedback are good ways to continuously improve your designs. So if you take away nothing else from this presentation, please remember the first 3 lessons I showed you. We want to focus our design on usage, not on product features. Design demands iteration and try to involve real users whenever you can. So those 3 lessons alone can help you avoid creating thoughtlessly designed products. So thanks, and I hope you got some information you can use from this presentation. If you'd like to learn more about the book or me or my company, there are some URLs there that are helpful. And what I'd like to do now is to pass the Q&A session back to Susan, who will field any questions people might have.
A gentleman says, CBS Sports. It automatically plays a video when the user enters a page. Any ideas why this might be happening and who's behind it?
No, and they probably don't want to reveal themselves to us either, do they? Because we'll find them. But, I've had the same experience with Twitter one time, and I don't really use Twitter, but, every once in a while I'll bump into some tweet that I look at. And let me see if I can remember exactly how this worked. I describe it in the book, where I was looking at a tweet that had an embedded video. The video played, and I decided I wanted to listen to the audio, but I didn't need to watch, the video display. I just wanted to hear it. So I was scrolling around, and as soon as that scrolled off page, the audio stopped playing. I mean, it didn't play the video anymore, even though I hadn't turned it off, but as soon as it was no longer visible, the audio stopped. All right, so I scrolled back to bring that, onto the screen, and the video was still progressing, but the audio had been muted. So I have to actually physically unmute it and then go back to wherever it was when it stopped. But the idea of continuing to play the video while muting the audio made no sense to me whatsoever.
Interesting. We could go on and on, I'm sure, for hours about
I have hundreds of examples
right.
at the website for the book, which is thoughtless-design.com. I had that, let me just pop back up here, thoughtless-design.com. I have some sample chapters, but I also have a supplemental list of other similar kinds of poor designs that I've written about. And I've got a bunch of links to other websites that have some of these same sorts of collections. And since I wrote the book, I've collected about 40 or 50 more examples from many people. It's all around us, and it's really frustrating for everybody. So you just wish people would learn these design principles, learn the lessons, and do a better job the next time.
Karl, we thank you so much for your time.
My pleasure. It's always good to be back with you folks. Bye-bye.